Okay, so if we multiply this out, there are multiple ways to do it, but I'm going to do -2 times x plus 3 here. So I'm going to distribute my -2. That's going to give me a -2x minus 6. And then give me an idea. Did you multiply that by the x minus 3 next? Where'd you guys go next? Or did you multiply these two together? Did you multiply this by x minus 3? Or did you multiply the x minus 3 times the x squared plus 5? Times this? Times that. Okay, this is what I would do. I multiply these guys. I mean, it's up to you. You can do it lots of different ways. You should get the same final answer. So if I multiply these, I do x times x squared is x cubed. X times 5 is a positive 5x. -3 times x squared is a -3x squared. And -3 times 5 is a -15. So I went ahead and color coded those so that you can kind of see how that comes up and what goes on with that or whatever. And then you have to distribute another time. So we started with 4 factors. We multiplied 2 together and 2 together. And now we have to multiply that last set together. Okay? So -2x has to multiply by everything. So I get a -2x to the 4th. -2x times positive 5x is a -10x squared. -2x times -3x is a positive 6x cubed. And then -2x times -15 is a positive 30x. So I did all of those. But then I got to do it again. So I got to do it with the -6. So -6 times x cubed. I'm just going to write them below here. Actually, I'm going to write them below their like terms. So -6x cubed is going to go with this. So I'll just write it below there. -6 times positive 5x is a -30x. I'm going to write that below the other x term. The fact that those are opposite each other is just a coincidence, just so you know. Okay. -6 times -3x squared is a positive 18x squared. That's less of a coincidence there. Those didn't match up, but they're both x squared terms. And then -6 times -15 is now positive 90. So that actually doesn't match up with any of those, so I'm going to add it on to the end. So we get a positive 90 there. And then combine my terms. So we just have, I'm kind of like adding this together on a slate here. -2x to the 4th. That -10x squared plus 18x squared is going to be a positive 8x squared. And then that -6x cubed and positive 6x cubed cancel. Same with the 30x's, and we have this plus 90. So my function is y equals -2x to the 4th plus 8x squared plus 90. So multiply them out, and then the y-intercept in this case, what's the y-intercept? Is 90. Good. That number is by itself there. Okay. Now, this is kind of a trick question. It's not meant to be, but it's a trick question in the sense that the answer is so easy that it seems hard. Okay. If we have standard form of a polynomial function, how do we change it to factored form? What do? If I give you standard form, so if I gave you this right here, how would you get to factored form? You factor it. Now that seems like a really hard answer, but that's exactly right. Okay? It's called factored form for a reason. Because to go from standard form to factored form, you factor the polynomial. Okay? So that's what we're going to be working on here. We understand now how to go from factored to standard. Now we're going from standard to factor. So we give you a little chart here. Most of this, again, should be review. Some of this is not. Okay? Before we can begin the process of factoring, we must first choose an appropriate method. So you ask yourself, actually, before any of that starts, I think my next slide. Oh yeah, it's up there. Okay, I'm actually gonna go to look at page 11 real quick because this should be. It's on the bottom of my slide, but it's obviously went to the top of yours, so I gotta fix that. But the first step of any factoring polynomial is to look for a factor out of greatest common factor. So on this little guy here, where's my chicken scratch? All over here? Not chicken scratch. Also, I'm ignoring you for the rest of the day. Okay, so the first thing that you do before you even get here is you go to a GCF and you look for that. And then you get into this and you ask yourself how many terms there are. Okay? Before I was trying to throw me off my game. Okay, so if you have 4 terms, you're going to use grouping to factor. If you have 3 terms, you're going to use the AC method. Now, some of us learned guess and check within this. If that sounds familiar, that's what you're doing there. This is chicken scratch right here. when you can't read it. Okay. It's math. And then if it's two terms, even degree, you can use AC method. A lot of us, what we talked about with this one, if it sounds familiar, is this is our difference of squares that we're going to factor with. And then the extra one that if anybody, even if you took algebra 2, that we'll be covering here, is that if it's a third degree, so if it's an x cubed, there is a cubes formula. Now I will give you that formula to use. You don't have to memorize it, okay? But you will be able to factor when there is a cube in the problem as well. So that's kind of our extra one that we have not covered before, but is part of the college curriculum, okay? So that's what we'll cover in there. So GCF first, and then you go through 4 terms, 3 terms, 2 terms. So for today, we're going to start with our GCF. So now I actually am on page 11. I don't know why that got moved, but that's okay. So GCF of polynomials. You are looking for how many terms it has. So for instance, number 1, this has 3 terms to it. Okay? It's a lot easier to follow the chicken scratch when you're not talking to your friends. Don't call it chicken scratch. Yeah. There's a lot going on. That's why I do that. There you go. I help you out. Okay, x cubed plus 2x squared minus 8x here. There's 3 terms. I underlined each of them, so you understand that. You look for the GCF, greatest common factor. What do they have in common? The answer here is they all have an x. Okay, if you want to break it down, this is real chicken scratch here for Briar. But if you want to break it down, x cubed, and you don't have to write this, but x cubed is x times x times x. 2x squared is 2 times x times x. And negative 8x would be a negative 8x would be a negative 1 times 2 times 2 times 2 times x. That's how you would break those down. So when we ask what's the greatest common factor, that's what we're looking at, is what factors do they have in common? Okay, well, every one of those has an x, but that's it. So each one of them has one x in it. I can't highlight the 2's because the x cubed doesn't have a 2. I can't highlight another x because the negative 8x doesn't have another x. Okay? So when you're looking for greatest common factor, if that's never made sense to you before, that's what you're really looking at. And I can draw that out more often if we need to, but that's what we're looking for. So my GCF here is x, and I want to divide each of those terms by that x. Okay? The x doesn't go away. The x goes out front when you're factoring out a GCF. Okay? X goes out front. And then the leftovers, if you weren't in my algebra 2 class, I call them the leftovers, okay, go inside the parentheses. So x cubed divided by x leaves an x squared left over. 2x squared divided by x leaves a 2x left over, so a plus 2x. And negative 8x divided by x leaves a negative 8 left over. So we factor out that GCF there. We're not going any further. So if you're looking at that like, hey, that factor is more, great. I'm glad you know that. We're just doing GCF right now. On number 2, you look for a GCF. Now, a lot of people get stuck on this one because they're like, what are the different terms? There are just 2 terms. The pluses and minuses separate the terms. Okay, so you find your 2 terms there. Does anybody think they know the GCF for this one? 3 what? Or more than that? Not x to the y. Don't listen to Briar. So there is an x and a y, but how many x's? Look at them separately. So 3, 24 and 9 you can divide by 3. Yes. So it's going to be 3x to the third, y to the third. Again, chicken scratch. Okay, 3x to the third, y to the third. So if you look at it, the 24 and the 9 will both divide by 3. X to the seventh, x to the third, they both have 3 x's in them. So that's x to the third. Y to the third, y to the seventh, they both have 3 y's. And then you only have z's in one of them, so you're not going to have that in the GCF. Okay, so we're dividing both of them by that. And then you do your leftovers. Briar, what's your leftovers that first one? Yeah.
7.
Nope.
8.
Keep going though. 8. Divide out the x to the third, what's left over? No y's. And then you have z's, right? Okay, so let's go over this so we understand this. You're taking and you're dividing everything by 3x to the third, y to the third. So 24 divided by 3 gave me the 8. Okay, x to the 7 divided by x to the third leaves 4 of them left. When you are dividing x's, you think about having 7 x's on top and 3 on the bottom, and 3 of those cancel out. So you have 4 left on top. Okay, y to the third divided by y to the third, all of them are gone. Z to the second divided by no z's means all of them are left. Okay, so those are my leftovers. The plus sign's there, plus, and then you do that again with the 9x to the third, y to the seventh. Michael, what's left over in that one? So 9 divided by 3. So do 9 divided by 3. 3. And then you have x to the third divided by x to the third. So those are all gone, right? And we have y to the seventh divided by y to the third. How many y's are left? 4 of the y's. So we're going to do y to the fourth. 3y to the fourth there. That's my GCF and my leftovers for number 2. Again, only doing GCFs here. Okay. Ashley, if you look at number 3, best guess at your GCF there. I like it. Okay, now I'm going to put a negative on there. I'm going to explain why. I wasn't expecting you to have it, but I'm going to say it's a negative 7x squared for my GCF, and then I'll do my leftovers. For what we're going to be doing, if the first term of whatever you're working with is negative, most of the time if you take that in your GCF, it makes the rest of the factoring easier. Okay, so we're going to take that negative in this case and put it in the GCF. Now, that does affect my leftovers a little bit here. So, Rachel, help me out. When you do negative 14x squared divided by negative 7x squared, what's left over? Good. And then what's left over in the second half? I like it. Negative 1x to how many? So we had 4, and we took 2 away. There you go. Okay? It's okay. You're good. But you got the negative. That's the hardest part there. Okay? Understand you're taking a positive 7 and dividing by a negative 7. You're going to have a negative 1. And she said 1. I didn't write the 1. Remember, it's assumed. You can put it there. Okay? And then we have that x squared that's left there. That's exactly right. I put her on the spot and she did it. Okay? Number 4. Cam, what's the GCF of number 4? It is x. Good. What's left over then, Cam? Okay, so from the x cubed, there's 2 different terms. From the x cubed, if you divide out an x, what's left over? You want to say it? There you go. And then I'm going to do a plus. Now from the x, y to the fourth, divide out an x, what's left over? How many of them? Did I take any of those y's away? So y to the fourth. There you go. Okay, that's our answer there. So you take out your GCF and you have your leftovers there. Briar, number 5, what's the GCF? Okay, I'm going to take out a positive in this one. Because the first term's positive, we're going to go positive, okay? So let's go 5x. Noah, what are the leftovers? Good. Now, there is what is called a disappearing one that happens. So some of you probably wrote 5x and in parentheses just wrote 5x. Okay? When you divide out, when you take this negative 5x here and divide by 5x, okay? Yeah, they cancel each other out, but they leave a 1. Okay? So if there's nothing left, you have to put a 1 in its place. So up here, when we were dividing y cubed by y cubed, the reason we didn't have to have a 1 in here is because there was other stuff keeping its place. Okay? Times 1 just would be just the 8 that's there, so we didn't have to do that. Here, we need that 1 in its place. Okay? So 5x with a 5x minus 1 left over in there is correct. Number 6, Caden, what's the GCF? It would be 1 in this case. And the leftovers? Hardest problem in the world. That was nice of you. And you kind of forgot the last. There you go. Perfect. Okay. Now, for the purpose of what we're doing, I'm going to say yes, that's the case. If this is the only question and it is just factor out the GCF, I would also in that case take there's no GCF. However, okay, however, as we go forward, there are times where we have to take a 1 out, and so I'm just getting you in that habit. Okay, if you said there's no GCF, that's okay here as well, but we want to get in that habit. Okay, so after we get from the GCF, if you remember our little flow chart, you don't have to come back to it, but the flow chart, we have to factor out the GCF, then we look at everything else and say, okay, how many terms? So we're going to talk about grouping now. So that's what's at the bottom of this page here, is how to do grouping. Okay, so walking through this, when we have 4 terms, we should factor a polynomial by grouping the terms. Okay, so what we do is we group them as x cubed minus 3x squared and 2x minus 6. Those are my groups. They've shown them grouped in parentheses. You can do it whatever way you want. That's fine with that plus in the middle. I don't like the parentheses just because I think it does get some other things later on confusing, but up to you. Then factor out the GCF. So in each one of those groups, you look for the GCF. So these 2 terms have an x squared in common, and these 2 terms have a 2 in common. So what they did is they factored out that GCF and had the leftovers, and factored out this GCF with the leftovers. That second GCF, you have to have a symbol with. So if it's a positive 2, you put a plus 2. If it's a negative 2, you put a minus 2. Okay? So you have that. So you get this correct. If you are doing this correct, the terms in the parentheses should be the same with this step. Because then technically you're doing one more GCF step. So right now, that term and this term are my 2 terms. What they have in common is the x minus 3. And if I factor that out, so imagine that goes away. Okay, I crossed it off there. My leftovers then are the x squared plus 2. And that's where we get to the final answer there. Okay, so that's my factoring by grouping, a reminder with those. Okay, and then we have to change our functions in that case. Okay, first thing is GCF. Second thing, if it's 4 terms, it's grouping. That's as far as we're going to go for today. Okay, so these 4 problems right here. Let's do this. You guys have the top left one. You 3 have the top right one. You 3 have the bottom left one, and you 3 have the bottom right one. Do your problem. See if you can do it. You're welcome to go be with your group, or you can just do it on your own. Do your problem.